Hey guys, what we just looked at was where it all starts at. It don't look like much water, but it doesn't need much water. We had a over average drought this year, but still yet we have plenty of water to do what we need to do. Anyway, we're going to take a walk on down and look at what we've got going on. Down here is where we have our generator. This is actually a windmill generating head that I worked with engineers from Italy to design a pelton wheel for the proper RPM and water flow. We have it set up on sprinkler timers so that we can actually turn on one valve at a time or all four, depending on the power, the amount of power that we need. When we get done today, I'm going to actually insulate all this, so I wanted to get a picture before we did that. My pressure gauge is frozen and busted, being that it's turned winter on me, but anyway, it's holding roughly 60 psi pretty much all the time, even under a full load. But anyway, the blue diaphragm air hammer we put here, so when the solenoid valve shut off, it absorbs the shock of stopping the water flow. We also have an air hammer about halfway up. One of these pipes has equivalent of probably, I would say, a fire hose when you open it up at a full 1.25 inches. It's pretty impressive. When I had a mishap and I shut one off quickly and I actually blew a pipe apart. There's so much pressure down here. But anyway, I've manually shut this off since I've been down here, and I'll go ahead and turn it back on, and then we'll walk up to the controller. But anyway, I'm going to turn on a couple of jets here manually so that we can see what she does. That's what it does, folks. Anyway, we'll walk up and look at the equipment up top. It's probably about a 500-foot pipe up there, so we'll get started. Up top here in the living room, by the kitchen actually, we have a voltage meter so we can keep a close eye on things. Right now I have a lot of stuff running, just trying to keep the voltage down because actually it's got my batteries full right now. So theory is, and either dump the electricity or quit making it. But anyway, we're going to step down into the basement here and take a look at that. That's not full power, that's just some of it. We're going to go down and observe how that all works right now. Down here we have our battery banks. We have some gel deep cycle. They're called Alpha Cell. I believe they're out of Germany. I did have a stack of 4 inverters. These are very cheap inverters, and having said that, I think I've got about 300 hours on them and only one of 4 works. So anyway, I wouldn't recommend buying them. But anyway, we have our charge controller here from Coleman Air, and it had its issues, but we've got them worked out. The way this particular one is set up is that this particular solenoid here, when the desired voltage is reached, it activates the solenoid, and what it does is on these 2 wires it breaks the connection to the sprinkler valves down on the water wheel, and it shuts them down. It has an adjustable setting here, so you can set your desired voltage. So anyway, when it reaches a high voltage, but I think we've got it set at around 55, it'll actually shut the water off to the wheel, and then it'll, when the voltage drops, then it will turn itself back on. I'll give you a demonstration here. I'm going to push the test button, and now it's turning off the water down to it right now. Okay, and now when that shuts back off, then it turns the water back on. Okay, alright, and currently we are running just 2 jets. We're running number 3 and number 1. And what I'm going to do is I'm going to turn the other 2 on just briefly. There goes another one.
And there goes another one. It's running about 18 amps. It possibly has some air in the line. We've had low water conditions. When you draw a lot of water, it will actually create a vortex because it's not in deep water, and it'll suck a little air in, and the voltage, or excuse me, the amperage will drop some. But overall, we have a little switch here so we can isolate between the windmill and the water wheel. These switches, when you flip them, they actually turn the windmill blades off. They lock them up. This is just a typical automotive, it's not a converter, it's a, dang, I can't remember what it's called, but anyway, it turns the three-phase electric into two-phase or to DC voltage, and then thereby charges the battery banks. That's a rectifier, I'm sorry, it's a rectifier. It also puts off about 180 to 200 degree temperature when under full load. We have it spaced off the wall to keep it cool. But anyway, that's how it works. Oh yeah, one more thing over here. The hot water heaters. We have a large electric hot water heater that we typically use, but in the event that we're running strictly off of the electric power off of the water, we have the smaller unit. And what we've done on the smaller unit is we've tied in this transformer into the thermostat. When the temperature comes on and it turns on the power, this transformer then sends power over to the switches and turns on more jets to create more power. When the water reaches the desired temperature and it shuts off, this also turns off the additional jets, thereby conserving on water. Well, not that we really need to conserve it because it, comes all the time, but anyway, that's how we've got it set up. And anyway, I'm thinking about making this a preheater for the dump load and just dump directly into the element, which would preheat the water before it goes into the large hot water heater. But anyway, that's how it all works. We've had a lot of fun building it, enjoyed every minute of it, and if we can ever afford to get a real inverter, a Xantrak or an Outback or something, then we'll upgrade this, and I can throw these pieces of junk here in the trash. But anyway, appreciate you looking at our video and hope you learned something. Thanks. Bye.